What is Lambda? Well, Lambda is a keyword in Python that allows us to create in a single line of code an anonymous function, a function that has no name. Now, why would you want to create a function that doesn't have a name? Surprisingly, there are a multitude of scenarios where this can be quite handy. But before going there, let's take a look at the syntax of a Lambda expression. Whereas in normal function definitions, the keyword def is utilized, in Lambda expressions, well, the Lambda keyword is utilized. Following that, and as this function is anonymous and doesn't have a name, we directly specify the parameter list of our function without any parentheses. The parameter list is defined as in any function writing the parameters separated by commas, while of course having the option to not have any parameter. Then a colon is inserted and a single expression is expected to be present after that. In this case, a plus b, and that's it. Notice the absence of the return keyword, as Lambda expressions are syntactically limited to only containing a single expression. This expression will be the thing that's returned, so the return here is implicit. If we try to print this Lambda expression, we can see that this in fact creates a function. Okay, and how do we use this function? One way to do it is to simply assign a variable name to this function object, and then we can call it just like we would call any other function. But binding a name to an anonymous function seems kind of counterintuitive, no? Well, that's because it is. If you want to have a named function, just do it the default way. So now arises the question once more. Why would we want to create a function that doesn't have a name? The short answer to that is to simply reduce the amount of code we write for simple, trivial functions that we want to use only once in our code. The first part is pretty straightforward, but why would we write a simple function that is used only once in our code? It's best to answer this by going over some examples. Say we have a list of names that needs sorting. We can easily do that by calling the sort method, and here we can see these names sorted. By default, strings are sorted alphabetically, but what if we wanted to sort the names based on different criteria, such as the length of the names? Well, luckily for us, the sort function takes as input an optional keyword argument called key. Key should be a function that takes as input any given element of the list we're sorting and returns the thing that represents this element when sorting the list. For instance, we can define a function getLen which takes as input a name and returns the len of name. Then we can pass this function as our key argument, and running this code we can now see the names sorted based on their lengths. That's a perfect scenario where lambdas can be very useful. This function right here is simple and trivial. Check. It is utilized only once in the code. Second check. And finally, this function contains a single return statement. Third check. So we can replace all of this with a lambda expression directly in our method call, setting key equal to lambda of name, which returns len of name. Comparing both approaches, we can see how using lambda made our code much smaller and simpler. Imagine having this logic embedded within a complex code structure. We'll have to define this getLen function somewhere far away from where it is actually used in the sort method. This makes the code much messier and its maintenance harder. Or you could define this function right above the sort call, but that's just bad coding practice. Other examples of functions that can take in this key argument are the min and max functions. Here's an interesting use case where I'm getting the max element in this names list not based on alphabetical order, but rather on the number of letters A each name contains. How cool is that? Another example that might interest data science folks is when using the Pandas module. Here I created a dummy data frame containing a single column A with the following elements. Say we want to create a new column A squared. We can easily do that by writing down df of a squared is equal to df of a dot apply and then specify our lambda function to be applied at each element. In this case, lambda of x returns x to the power of 2. Running this code, we can see the successful creation of this column. This once again shows the usefulness of lambdas when we need to create simple functions that need to be used just once in our code, such as when creating a function to be sent as an argument to other functions as we've seen in these examples. There are many more scenarios where lambdas can be very useful, but lastly, let me give you a word of advice. Did you notice how many times I mentioned the word simple in this video? Lambda functions are anonymous, so you can't give them expressive names. Also, Lambda functions cannot have docstrings and don't support type hinting, at least if you want to keep them nameless. On top of that, they are limited to only containing a single expression. So for all these reasons, please make use of lambdas when the function you're creating is simple and trivial and can be understood at a glance. Otherwise, revert back to using normal function definitions that are more expressive for more complex scenarios. Speaking of simple trivial tasks, here's one that can be easily written in a lambda expression. Don't forget to like if you want to learn even more Python.